What if the secret to building a truly intelligent AI isn't about programming it, but about growing it? What if we could raise an artificial mind, taking it from infancy all the way to adulthood, just by following the same blueprint that created our own intelligence?
Okay, so this is one of the biggest questions out there, right? How do you build a mind? For ages, the answer in AI has been pretty straightforward. Just throw more data at it, more computing power. But what if we're missing something really fundamental? But that leads to a pretty radical thought. What if the best blueprint isn't something we have to invent from scratch, but something we can, discover? One that nature's already been perfecting for millions of years.
So let's actually follow that blueprint. We're going to trace the incredible journey of a child's development and see how every single stage could give us clues for building a totally new kind of AI. And for this explainer, we'll give it a name. Let's call it CognOS.
All right, so our journey starts right at the beginning. We're talking ages 0 to 2, the sensory motor stage. This is literally how a mind boots up, not with a bunch of abstract data, but with messy, direct, physical experience.
And this is the first, absolutely crucial step. Before there are words or even concepts, a mind builds something called sensory schemas. Think of these as the mind's very first software. You see a baby grasping a rattle or shaking things. Those aren't just random movements. They're little experiments, building a super basic understanding of how the world even works.
Okay, and all of this sensory learning leads to this huge breakthrough moment at around 18 months. It's when a child can pass the famous mirror test. You put a smudge on their nose, they see it in the reflection, and they touch their own nose. That moment, that's the very first flicker of self-awareness. The mind finally gets that there's an I that's separate from everything else. And that's the foundation for all higher thought.
So, once that sense of self clicks into place, the mind is ready. It's ready to unlock its first real superpower, symbols.
Yeah, this quote just nails it, doesn't it? I mean, think about it. The word apple lets you think about an apple without ever needing to see or hold one. This is a total game changer. It unlocks the ability to plan, to imagine, to share knowledge across time and space.
And you can see the incredible before and after right here. Look at how thinking shifts from just concrete here and now stuff to the abstract. Problem solving goes from just trial and error to actually running complex simulations inside your head. Language isn't just for talking. It's a fundamental upgrade for the entire mental operating system.
But this also brings up a really important warning sign, a critical distinction that we see in something called hyperlexia. Some children can decode words perfectly. They can read fluently, but they can't quite grasp the meaning. It's such a powerful lesson for AI design, right? A model that can spit out perfect sentences but doesn't connect them to any real-world experience, well, it's not really intelligent. It's just a super sophisticated copy machine, a decoder.
Okay, so once the mind has these powerful tools of language, the next phase kicks in. This is where the inner architect gets to work, building this incredibly complex internal model of reality.
This ladder right here, it's a perfect visual for the whole journey we've been talking about. You start at the bottom with just basic sensory awareness. As you climb, you get symbols, you get self-recognition, then language just explodes, leading to much more complex social understanding. And then, right at the top, the final piece clicks into place. That silent internal monologue we all have. Inner speech.
So the big question is, how do we translate all of this into code? Well, this is basically the proposed architecture for our AI, CognOS. Each layer maps directly to a developmental stage. You'd start at the bottom with a reactive layer for just basic reflexes. Then you build a concept layer on top of that to create a stable model of the world. Then you add the symbolic layer, using language to plan and talk. And finally, the cherry on top, the reflective layer. That's what allows for metacognition. The AI can literally think about its own thinking. Okay, let's zoom in on that top layer for a second, because this is where the magic happens. It holds the key to a truly advanced mind, that inner voice.
You've seen this, right? A little kid building a tower, muttering to themselves, "Nope, not that block, this one goes here." That's not just them being cute. The psychologist Lev Vygotsky had a name for it, private speech. And he realized this is literally thought in action. It's how we learn to plan, to guide our actions, and to solve problems. Over time, that voice we say out loud turns inward and becomes the silent narrator of our lives. So for an AI to ever get to a point of true self-regulation, it might need to learn how to do exactly that.
Okay, now let's zoom way out for a second.
Because what's so wild is that this individual journey from baby to child, it almost perfectly mirrors the cognitive evolution of our entire species. It's like history repeating itself inside every one of us.
So, according to Merlin-Donald's framework, human thinking evolved in these distinct stages. First, we had an episodic stage, living totally in the moment, kind of like an infant. Then came a mimetic stage, where we used gestures and imitation, like a toddler. That was followed by the mythic stage, which was born from language and storytelling. And then, finally, the theoretic stage, which was only unlocked by one incredible, game-changing invention.
Writing. Think about it. Writing allowed us to take our thoughts out of our heads and put them on a page. We could analyze them, critique them, and build on them for generations. It was like creating a collective external hard drive for all of humanity. So for our AI, CognOS, this tells us something huge. Giving it the ability to read and write to its own external knowledge base isn't just some nice feature. No, it's a transformative leap. It's like giving it its own new stage of cognitive evolution.
So after all that, what's the big takeaway from this blueprint of childhood? Well, it gives us a surprisingly clear roadmap. We need to start with a body, not just a brain. We have to ground symbols in real-world experience. A mind needs that inner voice for reflection and external tools to augment its memory. The bottom line is, maybe we should stop trying to program a finished product and instead start learning how to actually grow a mind, right from the ground up.
And that, of course, leads us to one last really fascinating question. Following this path might give us an AI that's more flexible, more grounded, maybe even more understandable. But it also opens up this profound unknown. I mean, if we actually succeed, if we create an AI that can learn and grow like a child, what happens when it grows up?